I'm going to use the Laplace transform method to solve the first order ODE. Y prime minus 6y is equals to 2 sine 3t, subject to the initial condition y naught is equals to minus 1. So we are given that first order ODE there. And the first step there is to take Laplace transforms on both sides of the ODE. Then we have the Laplace transform of y prime minus 6 times Laplace transform of y is equals to 2 multiplied by the Laplace transform of sine 3t. And to obtain these Laplace transforms, I'm going to use the table of Laplace transforms. So from the table, we see that the Laplace transform of y prime is equals to s times y minus y naught. The Laplace transform of y, we denote it by an uppercase y, and the Laplace transform of sine of at is equals to a divided by s squared plus a squared. So substitute the values from the table, and then we have for the Laplace transform of y, it will be s times y minus y naught, and then minus 6 times y. And then on the right hand side, we are having a sine of 3t. Comparing it with this one there, we see that our a is equals to 3, so we substitute a equals to 3 into this expression, so that we have the right hand side is equals to 2 multiplied by 3 divided by s squared plus 3 squared. So that's the equation that we have now. We then go on and substitute our initial condition. This one, it is saying y naught is equals to minus 1. We substitute it on this part here, so that our expression becomes s multiplied by y minus minus 1 minus 6y is equals to 6 divided by s squared plus 9. And then we can go on and simplify this part. Minus minus 1 gives us a plus 1, so that our equation becomes s multiplied by y minus 6y plus 1 is equals to 6 divided by s squared plus 9. And then we can go on and factor the y there, so that we would have y multiplied by s minus 6 plus 1 is equals to 6 divided by s squared plus 9. Then the next step there is to go on and make y subject of the formula. So if we take the minus 1 to the right hand side, then divide by s minus 6, we have that y is equals to 6 divided by s squared plus 9 multiplied by s minus 6, then minus 1 divided by s minus 6. So that's our y there. And we then go on and look at this part here. In our table of Laplace transforms, we don't have any function which is of this form. So we have to rewrite it using partial fractions. So we'd have 6 divided by s squared plus 9 multiplied by s minus 6 is equals to as plus b divided by s squared plus 9 plus c divided by s minus 6. When we then go on and find the values of a, b, and c, we will see that our a is equals to minus 2 over 15, b is equals to minus 12 over 15, and c is equals to 2 over 15. We then go on and substitute these values here, so that we would have our expression then becoming minus 2s minus 12 divided by 15 times s squared plus 9 plus 2 divided by 15 multiplied by s minus 6 minus 1 divided by s minus 6. But if you look at this part here, the denominator there has an s minus 6. We can combine them so that it will simplify to minus 13 over 15 there. So our expression becomes minus 2s minus 12 and divided by 15 times s squared plus 9 minus 13 divided by 15 times s minus 6. So that's the expression that we have now. But if we look at this part here, we can just try to separate where we have the minus 2s and the minus 12, or write them separately, so that our fraction becomes minus 2s divided by 15 over s squared plus 9 minus 12 divided by 15 times s squared plus 9 minus 13 divided by 15 times s minus 6. So that's the expression for y that we now have. For us to get the solution, we will now need to find the inverse Laplace transform. But for us to find the inverse, we have to consult the table of Laplace transforms. So what we'll see there is the functions that we have there are of the form of the exponent of at and of the form cosine of at. And then the other one is of the form sine of at, because we are looking at the f of s that we have there and comparing them with the one in the table there. So if we look at this part here, it's almost similar to the Laplace transform of cosine there, but we just have to factor out the minus 2. So I will rewrite the highlighted part as minus 2 divided by 15, then multiplied by s divided by s squared plus 3. So that we can see there what is in the parenthesis there is similar to the Laplace transform of cosine of at. And then for the next part, this one here, we say that it is almost similar to the Laplace transform of sine of at, but we just have to factor out the 15 there, and also note that we are having a 9, which we can write as 3 squared, and when we write as 3 squared, then in the numerator there, we should have also a 3, so we would have to factor out minus 4 over 15, then it will be multiplied by 3 times s squared plus 3 squared. And then for the last part, this one here, we see that it is similar to the Laplace transform of exponent of at. So we can just factor out the 13 there so that we remain with the 1. So it will be minus 13 over 15 multiplied by 1 divided by s minus 6. So for us to solve for y, we then go on and take the inverse Laplace transform. So we would have that our y of t is equals to the inverse Laplace transform of y, which is equals to the inverse Laplace transform of the y that we have just written here. So that is how we get our solution there. We then go on and look at the inverse Laplace transform of this part here. We see that it's cosine of 3t. So that the inverse Laplace transform of the first function there will give us minus 2 divided by 15 multiplied by cosine of 3t. Then the inverse Laplace transform of this part here, we see that that's the inverse Laplace transform of sine of 3t, and you are multiplying it by a minus 4 over 15. So we have the Laplace transform of that part there is minus 4 over 15 times sine of 3t. And then on this part here in parentheses, we see that that's the inverse Laplace transform of exponent of 6t. So that the Laplace transform where we have the minus 13 over 15 there becomes minus 13 over 15 times exponent of 6t. So that's the solution that we have there. Then we can just go on and write these expressions that I've written here, substitute them here, so that we have our solution there is minus 2 over 15 cosine of 3t minus 4 over 15 sine of 3t, and then minus 13 over 15 exponent of 6t. So what we are having here, that's the solution of this first order ODE that we are given.